this Fireside will be super interesting. And as for the past like sort of panel and also the Fireside with Shriram, we are really talking about all the scalings for Ethereum. And for this one, we are super honored to have Eric to talk about like sort of the scaling solutions and also something about the upcoming new features for Bitcoin. And hopefully we have a bunch of Bitcoin holders here. Okay, first thing, Eric, can you do a quick self-intro here? Yeah.
Well, first of all, I want to say good morning, everyone. And let's try to not have a boring panel. Let's try to talk about stuff that people find interesting. Let's not make this like another snooze fest. I can't. I'm myself like dying in the audience listening to these panels. So let's try to talk about something interesting. My name is Eric Wall. Actually, I want to do like a roll-up specific intro for myself. So,
that's good.
my name is Eric Wall. I'm the co-founder of Taproot Wizards, the board member of the Starknet Foundation, the guardian of the ZK Sync, and delegate of Arbitrum, and investor of Celestia and Fuel, and the mother of dragons.
Whoa! I really love this long like sort of a title, you know. Yeah, definitely you are the OG like for rollups, especially on this ZK rollup side. I know there's a bunch of new innovations you're working on to scale like sort of Bitcoin, right? And can I just ask a quick question? Like, we all know all different ways to scale Ethereum. Then for Bitcoin, right? What kind of ways we have right now to scale it? And can you give a few examples and for the next few months, what are the new ones we can expect?
Yeah, so the story of Bitcoin and scaling Bitcoin is kind of a sad one, I would say. Back in 2015, 2016, the Bitcoin community had to make a choice between either we just increase the size of the blocks and we lose decentralization.
Yeah.
Or we try to do this channel-based scaling thing, which is called Lightning, which uses HTLCs and a bunch of weird hops and requires inbound liquidity, and it's this very, very messy thing. But it was a promising idea. Like this was when the Lightning white paper came out. When I read it, I was like mind blown because at least this opened the door and showed that we can actually scale Bitcoin and maintain decentralization at the same time. Yeah. Even though that we have to like manage stuff like liquidity and you can only receive a payment while you're online and stuff like that. So even though that it's very messy and very ugly, it was still like, oh shit, maybe we can actually, scale Bitcoin. So Lightning became the idea for how to scale Bitcoin, but something sad happened, which is at the time, I think the sort of elders of Bitcoin, the wise men of the guardians of the protocol, made the right choice to say no, like security and decentralization is the #1 priority, and we're now going to explore this new direction of scaling. And it hasn't been going that well with Lightning. Like it's for the people that work on Lightning. We just hired the founder of Mutiny Wallet, who's was developing one of the more popular Lightning wallets, and he basically wrote, I've been trying to do the best that I can with this protocol, but if we're gonna fix Lightning, if we're actually gonna make it work, we need some small upgrades to the Bitcoin system. But the problem with the Bitcoin culture is that after we won the block size war, there was a formation of a cult within the Bitcoin community, which is the Bitcoin maximalist cult, and promoting the message of Lightning that it is a perfect and like a final scaling solution that works and there's no reason to try to improve on it, became almost like a religious mantra. And if you want to be seen as a good person within the Bitcoin system, then you have to say that Lightning is good and it's going great and there's no problem with it. So we lost the sort of intellectual honesty in the discussions of Bitcoin. And if the elders were like still with us here today and we're faced now with new scalability challenges, I don't think that they would say, let's freeze the protocol, let's ossify, let's never make any upgrades, and like really try to make Lightning work. I think if the elders were here today, and like Hal Finney and even Gregory Maxwell, when they were talking about scalability back in 2013, they always talked about how zero knowledge proof is the end game for scaling.
Yeah.
And so now that zero knowledge proof technology is good enough and secure enough to actually that the Bitcoin chain could use it. Now we're stuck in this position that the elders are no longer with us, and we're stuck with this sort of religious people that think that there's no problem with Lightning, even though that none of them have actually used a real Lightning wallet. Most of these people use custodial Lightning wallets, which is the dumbest marriage between two technologies that I've ever seen in my life. You take a completely centralized solution and the most complex design ever, and you get the worst of two worlds. So you're centralized, but you still have all the inbound liquidity issues of the protocol, and that's what they believe is we should still keep doing. So the purpose of my company is to you cannot change the code of Bitcoin without changing the culture of Bitcoin. Yeah. So the reason that Taproot Wizards exist is to start at the layer 0 and change the culture and maybe get people to understand that there's another. We don't have to be like religious and eat only meat and hate Ethereum. There's another. You can't be a normal person and like Bitcoin and have like normal ideas about scalability, and we're trying to invite that type of community to become like a core part of the Bitcoin community, not just outside observers.
I see. That's so cool. Like, can you elaborate a little bit on this OPCAT? Because you are really like sort of how to advocate the OPCAT and try to really achieve like sort of these several new scaling solutions on top of that. Yeah. So what's OPCAT?
Sure. So can we do like a raise of hands? Who here in the audience knows what OPCAT is? Oh, that's very sad. That's only like 3 or 4 people. But OPCAT might be the next soft fork. Currently, it's the leading proposal for the next soft fork in Bitcoin. So all of us here in this room, Bitcoin is the $1 trillion asset, the biggest one, and we're talking about the potential, the number one candidate for the next soft fork in Bitcoin, and it's a kind of a big deal, but it's outside of the Bitcoin community. It seems like no one really seems to pay much attention to this. But I can explain what it is. So the Bitcoin has a scripting language, right? So there's Bitcoin script. You can do very basic things with Bitcoin script. For example, you have a UTXO, that's your coins, and in order to spend that UTXO, you have to prove that you have a private key. So you make a signature, or you prove that you've waited an amount of blocks. That's a time lock, or you prove that you have the pre-image to a hash. That's a hash lock. But that's about really the only thing that you can do with the Bitcoin scripting language. So what OPCAT is, it's an opcode. So it's like a small piece of script instruction. So Bitcoin is a stack-based. The scripting language is stack-based, and you have these items on the stack, and then you have these operators that modify the items on the stack, and the script has to come to true in order for a transaction to be able to be spent. And right now we have very limited set of these opcodes that we can use. We can only check very, very few things. An OPCAT is an opcode that the only thing that it does, it looks at these stacks that are on it looks at the elements that are on the stack. It takes the 2 top elements on the stack and combines them into one. So OPCAT stands for concatenate. It concatenates 2 elements on the stack. And if you know anything about like Merkle trees or cryptography, you know that concatenation is kind of fundamental to all the kinds of cryptography that we're doing. So if you want to make a Merkle tree, what do? You hash a thing, you can concatenate them, now you have 1 hash. And then you hash 2 other things together, and now you have 1 hash until you get to the top of the tree. Now you have a root hash and the Merkle tree, and it comes from being able to hash things and concatenate things, right? And Merkle trees, Merkle roots are one of the most powerful things that we have in all of crypto. Like that is the basis of Ethereum and Bitcoin is Merkle trees, right? But we can't in Bitcoin script right now we cannot check if a particular piece of a string actually exists in a Merkle root, or if a transaction exists in a Merkle root. We cannot do that. But if we had opcat, we could do Merkle root authentication on Bitcoin, and it's quite interesting because opcat was actually it existed in the original code that Satoshi. So when Satoshi,
then it was disabled.
So in 2009, and when Bitcoin was first released, opcat existed as one of the available opcodes, but there's a little funny thing with opcat that if you concatenate two elements on the stack and then you use another opcode that's called opdup, which duplicates the elements on the stack, and you concatenate and you duplicate them, you get this. You basically square the number of elements that you have in your witness each time you do that, and it very quickly your node will crash because you will have too much elements on the stack. It's so easy to not have this issue, but just setting a limit. Well, you check how much data is on the stack, and if it's more than like 500 bytes, don't add more. So the solution to like making to have cat and make it be safe has been known for a very long time. But Satoshi got kind of scared and he deactivated a bunch of, not only opcat, but he deactivated a bunch of different opcodes, like the opcode for multiplication. So we can't even multiply in the Bitcoin script. So in order to multiply, we have to do addition a bunch of times. So we can't do multiplication, we can't do division, we can't do concatenation. But if you wanted to improve Bitcoin so what I was talking about, like the problem of Lightning, if you wanted to do something better than the Lightning protocol and what even actually most Lightning developers believe, and even I think it has been a consensus in the Bitcoin community for a long time that the next upgrade that we should do is something called covenants. And I'll try to explain like briefly what covenants are. So covenants are a way to configure that when you're spending a UTXO, how the next transaction should look like that spends that UTXO. So right now, when you're spending a UTXO, you have to satisfy the spending conditions. But if you do that, now you have a new UTXO. If you have a covenant, you can say that, okay, well, if you fulfill these conditions, you can spend the transaction, but you have to make a transaction that has this shape or looks like this. And if you're able to do that, if you're able to put restrictions on how the new transaction that you're making with that UTXO, if you can put restrictions on that, you can actually create. You can turn each UTXO into its own little state machine, right? So you have a UTXO and it can only move around these different predefined states. So now you have a little computer inside a Bitcoin script, and then you could actually have state inside Bitcoin transactions. So you could, so now we get to the interesting part. So now you could, for example, update a state root in a Bitcoin contract, essentially, because you can carry state forward. So if you combine that with the Merkle root verification that you get from opcat 2, now you have the primitives that you need in order to build a rollup on top of Bitcoin. So with just concatenation alone, I actually didn't explain how cat gives you covenants, but it does through, and it also has to do with Merkle trees. It has to do with how transactions are constructed in Bitcoin. Is that you take each part of the transaction and you concatenate them and that sort of, and then you hash it at the end, and that top hash sort of describes the body of the transaction. But that means that you can, if you have the ability to sort of introspect individual parts of the transaction, then you can do that covenant thing where you sort of check, is this part of the transaction the correct part? Does it give you the right hash? So concatenation in a Merkle tree is like sort of allow you to introspect what's going on the stack, and it allows you to take a transaction, decompose it, and check the individual elements of it, to check the individual parts of it. So cat is 9 lines of code. It is probably the simplest possible thing that you could do with like the simplest possible upgrade that you could do in Bitcoin, but it unlocks this like crazy pattern of new functionality in Bitcoin. So it's the least amount of technical debt that we could insert into the system, and just by like some happy coincidence, it just unlocks all these Merkle trees, covenants, roll-ups, second layers on Bitcoin. So we could have like Bitcoin become competitive with Ethereum in terms of being able to host stuff like Validium chains or roll-ups or plasmas if we had OpCat. And so what we've done is, and this was, it's not, so the story of OpCat is kind of like, how did the Taproot Wizard team take this obscure little opcode that no one talked about and made it now be the frontliner soft fork that Bitcoin developers are talking about. And because actually at the last Bitcoin developer-centric conference that was done in, it's called BTC++, they do it in Austin. That's where like you get the highest density of Bitcoin developers. There was actually technical consensus at that conference that we're going to do something called great script restoration, but a part of that is actually, it involves reactivating cat.
I see.
And it used to be this like crazy idea that like getting cat into Bitcoin, like that's a crazy idea that no one wanted. But we have been, like our community has been educating and promoting and making some like code examples and sort of demonstrating for the Bitcoin community what cat allows and what it doesn't allow.
I see.
So people that used to be very afraid of what like cat could activate. So there's another covenant proposal that's called CTV that had a big grassroots community, and most of them were like very afraid of cat. And some of their leading proponents, like Brendan Black, he goes under the name Reardon Code, and Shinobi were like, no, cat's too crazy. The cat stays in the bag. Let's do CTV. Now they're actually saying, okay, because of the work that we've been doing with cat, okay, it turns out that cat isn't as crazy as we thought. Let's actually do cat and let's not do CTV, because CTV doesn't give you Merkle root authentication, so you can't actually do roll-ups or anything with CTV. So we have like a developer consensus. Rough consensus, I should say. There are some people that are very scared about cat still. I'm also a little bit scared about cat. We can talk some about that, because if you enable like expressive second layers on top of Bitcoin, is there a risk then that the MEV that is generated there leaks into the L1? That's a risk, and I don't think that it would happen. But that's me saying I don't think it will happen. And we're talking about now like risking $1 trillion asset because and I don't think it will be a problem. But maybe I gotta know for sure. So that's kind of where the debate is at the moment.
Whoa, that's amazing! It's a super like detailed explanation for almost all the history for OpCat and also these potential future rollups for this Bitcoin. And I just have one more specific question, because because we all know, right? If we fast forward, like assume like all the things happening on Bitcoin, we have rollout, have all the L2s. Like, do you think Bitcoin will have a similar problem like Ethereum right now? We have so many rollups on Ethereum, but most of the sort of rollup L2s capture the value, but the Ethereum may not really capture the value. But in the future, probably Bitcoin, the parent chain, the main chain, may not capture all the values.
Yeah, so I think if Bitcoin did the exact same thing as Ethereum and had a bunch of EVM chains on top of it, and they're all like struggling to figure out like how do we aggregate the liquidity and how do we cross-compose these things, then that could be as complicated as it is for Ethereum. It would be on Bitcoin as well, until someone like solves the fragmentation of issues of rollups. But if you just think about Bitcoin and you don't think about it as a DeFi chain, you just think, well, here's Bitcoin and Bitcoin the chain and the Bitcoin the asset, and what I want to do is I want to be able to make more transactions, and I don't want to have to use the Lightning Network. How can I do that? And if you just have a simple payment rollup, then you don't actually care about the MEV, or you don't care about the cross rollup interoperability. You can basically just think of it as a very good Lightning network that doesn't require channels. It's just off-chain computation for transaction aggregation, and you verify it with a ZK proof. That's still much better than doing everything at the L1 and increasing the block size. And it's also much better than trying to do it with Lightning and having this inbound liquidity stuff. So just build a payment rollup on Bitcoin using ZK rollups. And also, so another crazy thing before we wrap up is that apparently the Starkware guys figured out that Merkle trees are also the fundamental pillar to Starks. So circle, you can make a circle Stark with just cat. So you can actually create ZK proofs on Bitcoin with just cat alone. And that's like this crazy, like when I started promoting cat, I had no idea that was going to be possible. But yeah, the Starkware guys they really pulled like a trick out of the hat with that one. So yeah, we get covenants with cat, we get Merkle root authentication, and we even get ZK rollup verification. Now that's not super efficient to do, but it works. So it gives us sort of a, okay, we already have ZK rolls on Bitcoin, so we can say that let's actually soft fork another one and make a native ZK verifier that's more efficient, because you can already do it with just cat. So I think cat's like a great way for Bitcoin to get into ZK verification, because that's another like whole very complex problems to solve. Like how do we decide which type of proof system we want to embed into Bitcoin when the ZK space is moving so fast? But with just cat, we don't have to decide. It's just concatenation, and apparently it unlocks ZK verification, and that gives us a great way to start, getting our feet wet in the ZK verification space for Bitcoin.
Yeah, that's amazing to know all these new progress and also the futures for these Upcat, and also the probably future we can rebuild all the ZK rollups on top of Bitcoin. And yeah, that's all for the Fireside. We are super honored to have Ari to do this very detailed explanation and for the future of the scaling for Bitcoin. Yeah, that's amazing. Yeah, thanks everyone.
Thank you very much, all. Thank you.